Welcome to Bioinnov8. I'm your host, Rich Walcoff, along with Amy Ansel. And today we're talking with biological chemist David Abecassis, the CTO of Titan Bioplastics. And David, you are one of the leading interdisciplinary scientists with degrees in natural sciences from the University of Toulouse in France, a master's degree at Rutgers University where you studied biodegradation, and 10 years of research in the field of thermoplastics and nano-composites. I don't think anybody knows more about this stuff than you, a pioneer in the cutting-edge knowledge of biodegradable materials and sustainable plastics. And so much is being developed in the recent times on bioplastics. So tell me how you got involved in this and how far we've come in this long run that you've been at it for 30 plus years.
Well, I first got introduced to biodegradable plastics when my lab mate, who's now PhD, Dr. Chaudhry, was working on biodegradable plastics. And it was something that, it was an area of interest. I was working in other areas of biodegradation, which was more like the monomers that would make plastics. But I became exposed to it then. After graduate school, I ended up working for a polymer consulting firm, and that tended to be very, very diverse projects. So about 2.5 years after working for them, I left. So they were my first and last job as an employee, and then started my own polymer consulting business, which I had up until recently. And also from that point on, did everything from develop portions of consumer products that you're familiar with, worked with large companies. So we were oftentimes the innovation small company behind the large company. I've done work for everyone from Dow to BASF, looked at both licenses, innovation, and production of products for a lot of different companies, and everything from fire equipment right through to soil stabilization, high-performance coatings, different types of in-use environments that were unusual. And we did a lot of breakthrough work, and I think a lot of that was having the right people, having the right team, and a real sort of enthusiasm and love for what we do.
So
that evolved. Go ahead.
No, I was going to say, when we talk about bioplastics, we're essentially talking about sustainable organic matter that is used as a surrogate for a plastic or a fossil fuel-based product that is generally much more harmful to the environment.
Correct. Most plastics that are out on the market now actually are very similar to biodegradable plastics. They just lack a few key chemical features that allow microorganisms to break them down. So there's been some research into taking existing types of plastics and making them more bioavailable. But all that being said, all the bacteria that break things down evolved around a certain number of natural materials, and plastics from petroleum have appeared too quickly on the scene for them to evolve enzymes to break that down. I assume if you left it 1 billion years that they would. But so what the emphasis now is to go back into biodegradable materials and say, okay, we're going to use biodegradable monomers to make biodegradable plastics, but we're going to introduce those into traditional plastic rolls. And that's going to function like a regular plastic for the life cycle of that product. But when you throw it away, it turns to topsoil. And that's the idea.
Well, that's phenomenal, because we all know how damaging the old plastics are to the environment, and it's just horrific damage done to the ecosystem. Now, when you bring in the concept of nanotechnology, what exactly is that?
It's the use of very tiny particles that are nanoscale. They're basically very, very huge molecules, usually of ceramic mineral materials, but they can be a variety of other types of materials as well. And nano is based on the size, which is 10 to the minus 9th meters. So, it's very, very tiny at the molecular level. Now, why we say nano-composites? It started with work done by Mitsubishi in the 1980s using what are called drilling muds or clays that are the size of red blood cells, and seeing if they could disperse those inside a plastic. And clays like water, they don't like oil. It turns out plastics are oily materials. So they had to come up with a way to coat them with an oil to disperse them. When you did that, you got a new type of material, because these little microscopic porcelain plates, if you want to think of them that way, have dispersed uniformly throughout the plastic. Still looks like a plastic, processes like a plastic, but it has very different mechanical and chemical properties, and it also processes differently and more easily than a plastic. So there's the field of nanocomposites boosts material science's ability to use high-end application from low-end polymers, basically.
And the toxicity level is so much less, I would imagine.
Correct. Now, we work with green. We grow green nanocomposites, meaning they're safe, they're non-toxic. However, there are technologies out there that were originally used, such as quaternary amines or resorcinol phosphate, that either had some sort of hazards if they were heated inside an extruder. So, for example, quaternary amines will give off a gas that you shouldn't really breathe. And then also resorcinol phosphate, which I helped innovate at the time. It has environmental restrictions, so the material that you make it with is hard to transport, store, and if there are any accidents, it's considered a hazard. It's a class 9 hazard. So here we're using new generation nanoparticles that have no environmental liability, so that when our plastic nanocomposites, our biodegradable nanocomposites break down, the nanoparticles will just become a natural part of the environment and don't introduce any sort of hazard.
So, David, what are you saying, that there's a sustainable route to nanotechnology and an unsustainable route to nanotechnology?
Correct. And I would say even, nanotechnology opens sustainability in a couple of ways. Even the other types of, recycling plastic is a big item. The problem with most of the other types of nanoparticles, they're expensive. So we're able to work within the realm of what is acceptable in commodity plastics. But by using nanoparticles that are environmentally safe, we're able to boost the properties of these plastics. So we can do bigger and better things that you would normally use more expensive or higher end materials to do. And so you use a sustainable polymer and you marry it with a nanocomposite, you can now control how long it lasts. You can get the kind of field life you want. And then when you're finished with the product and you dispose of it, it biodegrades and contributes to the topsoil.
So how does nanotechnology relate to this material called graphene?
Okay, so graphene is it's a superconducting molecule within itself at room temperature, and it's been very useful to physicists actually, which helps their understanding of the universe. It's a product that can be produced from a variety of sources. Hemp is certainly one of them, other types of plant material or others, and it's added into plastics for a couple of different reasons. One, it makes the plastic electrically conductive to different degrees, and that can be everything from using it as a plastic EMI shielding that's lightweight for avionics or military applications, right through to giving it better barrier properties so that you can use it as a packaging solution. And so graphenes have a lot of emerging importance. Purity grade, they also compete with other types of allotropes of carbon, such as carbon nanotubes, which are also nanoparticles, and those can have varying toxicities. Graphene is, I think, right now considered fairly safe to work with compared to some other types of nanoparticles. So it's
and do I understand? Go right ahead, please.
It's a whole industry and development, and we plan on taking a leading role in that. From the raw materials that we're going to work with, we're very interested in developing graphene production strategies as part of our overall process flow.
And do I understand it's among the strongest materials ever tested, graphene?
Graphene, in some ways, if it's put into certain types of configurations and can be made into a fiber and linked, you get extremely strong bonds, and those bonds are stabilized even more by this very unusual electronic structure that graphene has. So it's a very, very stable molecule, and you can make materials using it that have very highly enhanced strength. You can think of it a little bit the way you make steel. Steel is basically just iron with, not a lot of carbon in it. But if you add other types of metals, you get very high-end alloys. And so I think graphene can be seen in that respect. It takes biological materials or plastic materials and converts them into barrier materials, electronic materials, And who knows, eventually, if it's done correctly, graphene could be a source of transmission of energy without loss to Joule effect, if they can ever develop it further. And this is the next level of research, taking it so you're actually producing a plastic conduit that holds a form of graphene that carries electricity with no heat being generated whatsoever. Now you're saving energy. You're also using plastic, which is environmentally stable, and there would be a lot of benefits to doing that as far as the way we consume electricity.
You know, you're developing these new materials with the nanotechnology. How is it being used today?
Today, we're using it to get greatly improved both mechanical properties, barrier properties for certain types of sensitive material packaging. We're using it to blend plastics that can be conventional plastics or biodegradable plastics in a way that they would normally never blend. We're producing superior mechanical properties at several levels and boosting the value of the plastic tremendously with a small amount of additive that's processed in certain proprietary ways.
And your target clients for these new technologies, the nanotechnology, would then be which?
Everyone that's using plastic for anything now. So if we're looking for something that's got a product life cycle, we're simply looking to identify the product life cycle requirements and then come up with a biodegradable or a green plastic version of a solution that now is sustainable, that can either use recycled plastics, be recyclable after disposal, or be biodegradable.
Well, it sounds almost too good to be true because it sounds so phenomenal. Now the question comes, is it affordable? What's the price point versus the traditional
It's very
plastics?
affordable. It's very affordable. Biodegradable plastics are within the same ballpark price, so they're in the range of commodity plastics. Our version of nanotechnology fits into that pricing scheme elegantly. So even with our nanotechnology, you're still well within the realm of what the type of pricing you would see in polypropylene or polyethylene or other basic commodity plastics. So that means that with bioplastics, we can really enter a large spectrum of markets if pricing is the issue of entry. But we're able to get these nanotech properties within the range of what you would normally be working with commodity plastics for. So the cost is very similar to what's existing now.
Mm-hmm. What do you think would be the most important compound that you've created? And maybe talk a little bit about the formulations that you use for more of the scientifically inclined listeners.
Well, I think we have a delivery vehicle called a master batch that delivers our nanotechnology into a wide variety of other people's plastics. We are called on to replace those plastics with biodegradable plastic. There are situations where they just want our nanotechnology expertise in conventional plastics. And that could be for any number of reasons. One is, which is very environmentally friendly, is to increase the shelf life of packaged materials. There are a lot of pharmaceutical materials that are extremely expensive, and when they go bad and you have to throw them out because of moisture and oxygen and microbes, it's a loss. And so we're able to prevent those kinds of losses by modifying existing materials. We're able to make materials that can be used for construction, whereas normally the material would have to be used for landfill. And that's because we can meet certain types of flame retardant requirements for a variety of building materials. We're very familiar with those. And so we can take disposal plastic that would head for a landfill, and we can actually use it for a lot of commodity things, everything from target-directed, municipal benches near a park, right through to earthwork reinforcement, beams, right through to local products like, skateboards to tourists. And so we're creating local economies for materials with this. So materials don't have to be transported as far. That's a savings in carbon footprint. We're also, instead of disposing materials, now reintroducing them into the manufacturing economy. And that cuts off this produce and dispose of undisposable plastic paradigm that most of industry has been working on. up until recently.
You know, when I think about when you describe the new technologies, it seems absolutely unconscionable that corporations or governments would opt for the fossil fuel-based plastics versus the biodegradable nanotechnology that's out there. What do you think is the biggest obstacle to its advancement to this point? And what will jumpstart, other than interviews and conversations like this, to embrace the new technologies?
That's a great question. You have to remember that most manufacturers, when they sell a product to the public, they have to get certification and tests. They're also in a price competitive market, and that makes them hesitant to take risks with products where they're going to have to pay for that recertification all over again, either through UL or ASTM or some sort of consumer organization. And that's seen as a barrier of cost. That has to be overcome by the either increased client preference, meaning clients will buy your product now because it's biodegradable and you'll see an increase in sales. Okay, now you can go back and register that. And also, I think just the entry of bioplastics into applications, it's been limited really to spoons and forks and, you know, plates and some basic commodity items. But I think we're really filling the niche at Titan Bioplastics of expanding beyond those commodity uses into normal plastic uses throughout industry. And I think it's really been the application expertise combined with knowledge of bioplastics that's probably held us back. We're hoping to catalyze that and change that.
You talk about the role of industrial hemp in bioplastics, because it seems to be that secret, hidden in plain sight ingredient that is fighting an uphill battle to gain acceptance in the commercial world.
Well, and this is because it's introduced in many ways in places where you could introduce nylon. It makes extremely good ropes and fibers, and that's why it was used for ships and building the pyramids. But in that respect, it's similar to why we use nylon today, for example. There are nylon ropes and cords that pull ships to shore. It's a very, very strong material. In addition, nylon is made into things, not only hairbrushes, but also goes into plastics to increase their strength as an additive. And in this respect, hemp fiber is just a natural fit for that. I think it's simply a question of large established manufacturers are prone to having protocols they don't want to deviate from. And so when you're introducing hemp versus nylon, there may be fiber diameter differences you have to account for. There may be a certain number of things that cause them to change their protocol. And so it's like changing the direction of a large ship. I think that's just an inherent resistance that any business has to any new technology if it's manufacturing something.
David, in regards to the manufacturing, I understand that you have something coming out real soon about asset protection and how this will really revolutionize the pharmaceutical industry in regards to drug piracy. Could you elaborate on what you're doing in this innovative space?
I have some restrictions simply because we're in patent, but I can explain. We have found a way to create a low-cost signature, a low-cost chemical signature that's deposited on packaging, and it not only is almost impossible to duplicate, it also changes from batch to batch. So when a pharmaceutical is made, it'll have a unique signature. In addition to that, this packaging technology allows you to see if temperatures were exceeded in any way. If moisture was
You cut out there for a minute. Can you repeat what does it allow you to do?
It allows you to measure how the material has been stored. It measures storage conditions, transport conditions, and it also gives a unique signature to each batch of pharmaceutical or consumer product you're trying to protect. Does it in a low-cost format and a highly accurate format that's almost impossible to reproduce.
From what I understand, the bioplastics products from biomass sources. So we're talking about readily available vegetable oils, cornstarch, yeast that trigger this chemical process to manufacture these sustainable, biodegradable, so-called plastics, the bioplastics?
Correct. So plastics are always made from monomers. Plastics are polymers. So nature uses a variety of monomers to do a couple things. Proteins are polymers. Starch and cellulose are polymers. And then in the case of hemp, cellulose is a particularly crystalline form that's the strongest in nature because of the way it's wound. That has unique industrial value. But it's all polymers, whether they're plastic or natural materials, are made up of monomers. So by using our knowledge of biomonomers or biomolecules, we can link those together and make large, heavy materials that you can manufacture with that we call plastics. But it's the same concept for a tree making cellulose for itself as it is for a synthetic reaction at a large chemical company making a polymer that will then be used as a plastic. We're using monomers to create larger molecules, and we're assembling them in such a way that we're getting specific properties. Nature does that with biomolecules, and it's the same thing with bioplastics. We're just kind of merging the two worlds.
You're kind of picking up the ball from maybe the great old Buckminster Fuller days a generation ago, the creator of the geodesic dome, who also, I understand, did research on carbon structures and graphene tubes, creating new materials and devices. Is this just the next gen of his initial research?
That is correct. The Buckminster Fullerene is named after him. It's a complex molecule made up of carbon. His name is on the fourth allotrope of carbon, which are carbon nanotubes and carbon nanoparticles, of which the Buckminster Fullerene molecule is one of. But so are multi-wall carbon nanotubes, single-wall carbon nanotubes, and graphene. And these are all, and we're familiar with diamonds, graphite, and carbon and other forms. But it's the fourth allotrope of carbon, so it's a big breakthrough in material science.
And it sounds as though you're really on the cutting edge of this, but maybe again we harken back to the challenges to have corporations and maybe nations at large to embrace new technologies because it is challenging the old paradigm. So obstacles and opportunities are right before you.
Right. And so what MIT studied a lot of acquisition of marketplaces for new technology, and they came up with sort of a Gauss curve, and they showed that in the first 3 years, if you get 1.5% of your market leaders that will kind of acquire your product and use it, everybody in this group, by the way, says they like your product. So it's 100% believers in your product. It's just they're not going to stick their necks out to acquire it until in the following stage, the early stage leaders are going to, they're going to want to reference those first stage leaders and say, did it work out? Did you get good sales? Okay, we'll take it. And now you go up the Gauss curve. And then the late stage acquirers, again, from the same pool of people that love the idea, they're just cautious to different degrees about implementing it in their product line or in their use. And that's just the way all technology innovations, grow.
Mm-hmm. Which country and companies have been most receptive to the new technology, the nanotechnologies, the bioplastics? Because it appears as though in America we are behind the curve.
I would say that, in Europe, Germany has recognized the value of this. I think all large academic institutions now have nanotechnology and nanoscience people. They're all doing different things. And in some ways, nanoscience is interdisciplinary. So it's a wide variety of things under one umbrella with, a teeny-weeny particle being at the heart of it. But I think that all that being said, if I was going to look around the world, I would say that in nanoscience, Japan has led the pack along with Korea as far as application and patents. And I think Germany, because of the agricultural nature of parts of Europe, particularly France, but also parts of Germany, and also its background in pharmaceuticals and materials and chemistry, I think the Germans are taking the lead in this area. as well. And there are Latin American countries, I think, that will want to step into this new domain and say, this is the key to sustainability. And yes, by the way, sustainability is economically a competitive way to do business.
Well, I'm understanding that IKEA in 2020 will require all its plastics be bioplastics. Legos is turning its little plastic, structural entities into bioplastics. So slowly but surely, the tide is turning. But obviously, here in the States, we're fighting that uphill struggle. So what do you think would be the catalyst to expedite the embracing of the nanotechnologies and bioplastics here in America?
Educating farmers, because really we're switching from petroleum to agriculture again. And agriculture is going to be the basis of our sustainable economy. So producing value chains, supply chains, vehicles, education that allows farmers to be part of a more sophisticated industry. That would be one part. I think there's a role for local municipal governments, industrial associations, in accelerating that. And then also, educating the public, who is basically going to make consumer choices about what they'll pay more for, what they'll support. And I think if we combine awareness, public awareness of why sustainability is good, why you're creating local jobs, at the same time we're doing this, we're creating local indigenous jobs in those communities. I think that speaks for itself. And I think also the environmental cleanliness of, it's very important. We have an aging population. People want to live in a nice, clean place. And I think that's the biggest benefit.
Well, you talk about agriculture because agricultural waste has been a key influencer in dead zones in the oceans, which have become absolutely horrific.
And I'm glad you brought that up. We are pioneering sustainable methods of agriculture. I've actually taken a personal lead on some innovations in that space that eliminate or reduce the amount of nutrients and use cyclable materials for high yield agriculture. We're involved in that at a cutting edge level right now as we speak, and that's to enable organic agriculture, which I think will be the trend for the material space as well. We're going to have more and more people want to say, listen, you didn't pollute the ocean growing this stuff to make my plastic.
Right. Now, what I understand is the nitrogen in the fertilizers that is draining into the rivers and into the oceans that's causing the hypoxia, the low oxygen in the water.
That is correct.
That's starving the marine life and hurting our environment horrifically. But I'm understanding as well that GMOs that are using, in America, 90% of the U.S. corn has genetically modified corn, but they're absorbing more nitrogen. So the Monsanto, Dow, and major chemical corporations are finding a different path to address the problem, but does it exacerbate the problem on other levels? And your sustainable bioplastics approach seems to be far more advantageous in the big picture.
Well, first of all, there are some things that are, everything that you eat has been genetically selected for at some level. So personally, as someone who's trained in molecular biology, who understands its benefits when it's correctly used, I don't think it's automatically the bad guy as far as technologies. If you can clone a gene for a pesticide that's a biopesticide into a plant, and you can direct it specifically and control that, there are situations where it might be an acceptable technology as long as it's not disrupting the rest of it. I think to say all GMOs disrupt the ecosystems, blanket, non-restricted, non-regulated GMOs have a lot of pitfalls, and I think that's been part of it. The idea that we're going to get better yields using organic methods and using natural plants, remember, we'll still be selecting for those plants. We're just not going to transform the environment quite as fast. So anytime you're planting, anytime you're growing trees, growing plants, growing fruits, growing vegetables, you're transforming that environment. And as you increase the right kind of vegetation, you can get a more varied diet, a healthier diet for local people, but you also get, an ecosystem that becomes healthier. You have to kind of understand what that means where you live. And I think one of the things that hemp has an advantage in, along with its cousins, is that it's a very adaptable plant that puts in nitrogen but holds it in the soil with a root mass, meaning I'm giving the microbes a bunch of carbon. They're going to need that nitrogen. They're going to need to keep it local. And certainly I've actually developed processes in my inventor life that take all the nitrogen out of cesspools and septic tanks at low cost. I was one of the first inventors to do that, so I'm intimately familiar with the marine issue. But here, if we're using hemp actually fixes nitrogen, and then we keep the nitrogen localized. And then there are green organic practices we can do that actually would reduce nitrogen pollution generation tremendously. And also looking at the solution that hemp, not only as a nutritional supplement, it's got protein and everything else, but it is a replacement for pulp and paper, which in the Southeast and other parts of the country, they clear cut everything and put pine trees to grow quickly, and that disrupts the ecosystem tremendously. Species that were indigenous to hardwood temperate areas, they're now leaving. You can replace that with a crop that you can have multiple harvests a year, increases the soil quality, and has so time-release nitrogen that it fixes, then you're not making synthetic fertilizer as much, and you're using better practices to manage what you have. I think that's certainly a way to get to lower leaching of nitrogen into marine environments and lower amounts of phosphate in freshwater.
Well, we got to clean up this plastic soup, as it's called, in our oceans. I was reading about in the 1960s, there were 49 dead zones worldwide in the oceans on our planet. There are now over 400, some the size of France, and some
Correct.
in the Gulf of Mexico and off of our southeastern coast are just horrific.
That's right. And there's something like 1/3 of all the biomass in the oceans that's been calculated to have the equivalent in plastic floating around right now. So that's a lot. When you think of all the Sargasso seas and all the biomass, the blue whales, everything else, you've got 1/3 of everything living in the oceans in the form of plastic floating in the oceans. So it's something that we're going to make a difference in by switching the economy to this. We'll make more judicious use of consumer products. You don't need to really buy something new and throw it away the next day, 3 times a week. And I think consumers are being educated in that respect. We need to have better land practices so we can switch away from a petroleum-based food economy, which right now is the only thing that sustains a large population. We have to have high-performance organic methods that produce enough food, not just switch over to organic. And so, we've gotten addicted to this petroleum fertilizer economy. By switching into these types of new biotech breakthroughs and also use of sustainable agriculture like hemp, we're kind of cutting the need for that and making food economies more stable and safer.
And when I see that the plastics that dissolve over time in the oceans, they become microbes that are consumed by the marine life, goes into the food chain. We eat the fish, and maybe that's one of the reasons we're having more health problems and an increase of cancer incidents. Tell me your thoughts on that.
Well, first of all, cancer incidents are a variety of things. First of all, we're living a lot longer. It's the second cause of death worldwide. I think that certain types of compounds may be influencing cancer rates, and I'm thinking of the different types of cross-linkers. Bisphenol A, for example, that's used in plastics or was used as plasticizers. Those are biomagnified up the food chain. Really, the things that are dangerously magnified up the food chain are certain types of monomers, ones with chlorine in them, fluorine that are stable, that can go up into liver tissue, and then the big fish eats the small fish, and it gets concentrated up the food chain. We know that biomagnification is the most efficient way to transfer a chemical into a living ecosystem there is. It's 100% efficient with like mercury in the lakes in Minnesota, for example. And they've done a lot of work towards this. So biomagnification up to trophic levels is a big item. Now, if plastic such as polyethylene or polypropylene gets broken down into its monomers, The microbes that eat that are just normal microbes. So the blue whale and the fish above it are really not going to be affected, except that maybe there's a few more bacteria, maybe there's a few more fish. It's different types of polymer monomers like the styrenics. They have a benzene ring inside, and that can create carcinogens, mutagens, and things like that. When those compounds break down, they do form toxic compounds. So it really depends on. Now, nylon is very, very, very similar to our protein. So when it breaks down, unless it's got a plasticizer, it's really going to go back in the food chain. But styrenics, if they break down, those are the ones you'd want to concern yourselves, that and certain types of chlorinated polymers. Those are toxic to organisms, and those would concentrate up the food chain. The other one would probably just make more biomass if they would just break down to begin with. The problem is they're not breaking down, so a fish swallows a piece of plastic, dies because of obstruction in its intestine. So that's part of the problem now.
So let's talk about the
Go ahead,
solution.
Amy.
Oh, thank you. Let's talk about, we are at a fever pitch with a problem, clearly. And I think that what I'm present to is the consumer cry for sustainable materials. And I think that might be one reason why we are gaining momentum. David, how long have you been studying and researching hemp? Because right now you're with Titan Bioplastics, which is a formulations company. You have done 30 years of research. So right now you have formulations that are ready for the marketplace. And that might be a huge misunderstanding for the Fortune 500 or the Fortune 50, is that people like you don't exist, and that there's this type of advanced plant technology isn't around, yet it is. Can you speak to the recent formulations that you have in hemp, how long you've been working with hemp,
Sure.
and how these are going to transform?
So hemp is wide. I've been handling hemp hemp fiber since my days on a farm in Alabama, where hemp is the rope you bale hay with and handle hay bales with. But on a technical level, we've developed formulas based on fiber knowledge of plastics. And again, looking at hemp as what it is, nature's nylon. We've been able to transpose, 20 plus years of experience with the nylon fiber into really looking at how to make optimal use of the hemp fiber. So we've got master batches with that. We've got a variety of products with it that are not just only plastics, but also environmental products that we've got developed, and some others that take advantage of its properties. So we've got several ready to go, market ready products for the plastics industry, but that have a lot of experience, behind them. And I think that being able to use hemp has been sort of a turnkey for a lot of the things we've done before. And a lot of the properties confirm themselves. So we're adding experience from the plastics industry with additives with what we know about hemp fibers, which is more recent in my work.
Are these formulations for like barrier, moisture proof, or?
Yeah, all kinds of mechanical properties such as tensile strength, flexural modulus, also having a stronger biodegradable material that you can use a biodegradable plastic with. We are looking at different types of barrier and packaging, as well as possibly even some higher end uses that plastics would see, such as automotive, aerospace type things. So that has been really liberated, I think, by the inherent properties of the hemp fiber.
And it's not just nature's nylon, with the hemp seed to make hemp milk, the flour to make pasta.
Correct.
Food,
Correct.
The oil to make
Correct.
the biodiesel, the pulp and the fiber, hempcrete, the herd. So there's so many applications for hemp, from food to protective devices, storage, oils. You talk more about that, please.
Sure. So hemp is a good source of protein. In fact, I love the way hemp seeds taste, but it's a really high quality kind of protein. You've got a lot of oils that are very healthy. There's a lot of medical research showing that extracts from hemp are unusually good for human health and animal health. And it's because they're used for everything from neuropathies where they currently have FDA approval, things like epilepsy. But there's a lot of, let's say, testimonial cases of a variety of ailments, everything from insomnia, digestive disorders. There seems to be some evidence to show it's got a positive effect on the immunological system. It also tends to accelerate apoptosis in certain types of cancer cells, which is coming out of research, and that's extremely interesting. There are neurodegenerative diseases, organizations, I believe, such as the NFL, that are looking at concussions now, boxing leagues that are looking at how to use hemp extracts to minimize concussions. And so there are certain compounds in hemp that may be future breakthroughs in medicine. I think that's really just starting to develop. And we're seeing early stages of it now be pharma approved for pharma use. But, GW Pharmaceuticals did get approval on a cancer drug using cannabis, and there's been quite a bit of research into that area. And so I think medicinal uses of extracts from hemp will play a big role in future medicine and medical products.
So the phrase I like to use is that plastic kills and hemp heals, with the CBDs and the other factors that you mentioned. I also noted that 70% of industrial hemp in the world is grown in France, and China is number 2. And where is the USA? Where it's still illegal domestically to grow unless it's for research, but very limited, correct?
So there are a couple of forces at play. And, one is that places like France and places like China have government structures that allow them to do something different. They're not quite as influenced by special interests. And we have a system where private special interests, dominate our political system. So when something is kept illegal or something is seen as associated with, like the repression of the cannabis industry, for example, then we tend to rationalize those policies over time, and we tend to maintain them. There's been an ongoing battle between different forces, the Hemp Farmers Association, Big Pharma that obviously wants to get their hands on in a monopoly fashion on the field, once FDA regulation allows for that. Then there have been a variety of special interest groups, both private, non-for-profit, and organizations that have had different roles to play. People that don't want to see hemp develop, for example, Cotton Growers Association may not want that, or another type of agricultural competing fiber. There are agave fibers that are being used. Those are different crops. They're going to have different lobbies, and those lobbies will have conflicts of interest over markets. And I think it's just natural that something like that is going to play out as you go into this. So the United States situation has been very different, and there's been a lot of anomalies throughout the world as people start to regulate cannabinoid medicines, including extracts from hemp. While Canada has seen its really a liberalization both of recreational and medicinal cannabis and a mail order system, their laws about CBD have been actually far more conservative than ours have been, which are still in some ways considered food grade, but are being debated at the federal level, where obviously there's this big fight between large pharma and the people that want to use cannabinoids for nutraceuticals. So I think that's going to play out politically here. And I think the hemp industry reflects that same trend. We have large lobbies that don't necessarily have the public interest in mind that result in anomalous sort of public policy.
It's kind of a mixed bag too, though, David, because, the United States used to grow over 16 million acres of hemp every year back in the day. And we even had a $10 bill with, hemp production on one side and big industry on the other, like in the early teens in the 1900s. So, as the government has patents efficacious in nature, what they're claiming from a medical perspective, it seems like government and politics are on both sides of the fence.
There's no larger, more powerful lobby in the United States than Big Pharma. We have the highest per capita cost for pharmaceuticals here of any place on planet Earth. Now, the rationale that we're always handed is that, we pay for the research that gives it to the rest of the world at lower cost. No, we get taken for a ride here and really just pillaged on drug costs. I'll give you an example. I had Lyme disease. So I had a monosodium version and a disodium version of the exact same molecule. The disodium version was $10 a pill. The monosodium version was $1 a pill. Same exact substance. And then there are other examples where costs are astronomical. And the rationale is always given that, well, it's the cost of R&D. But yet, if you look at other countries, they have huge R&D programs as well. So I think it's really that, the pharma industry owns Congress is really the best answer as to why our pricing is so high. And so that is the most powerful lobby. Everything around policy resulting in health policy, they will dominate Congress financially completely. And that's had a huge effect and will have a growing effect on this industry, unless there's the counterbalance of public opinion that makes it impossible. And I think here's where patient advocacy is sort of a bulldozer that even politicians can't stop. You can't stand in front of a guy in a wheelchair and say, this guy's bad for something that's from nature. You can't take a 9-year-old epileptic child and say, you're breaking the federal law. And I think that that's what's created the cannabis movement and the hemp movement, which are kind of converging around CBD and other extracts. And that will be the counterforce to the large politics.
Well, and we're more of a global stage, too. So those pharmaceutical lobbyists are now playing at a global level. And when you look at what Europe is doing and other parts of the world in the healthcare space, their laws, their global laws are antiquated and weak. Other countries are ignoring us at this point.
So, Germany, in my personal opinion, is an example of where pharma has had a large influence. You can only have crystalline isolate CBD if you are a pharmaceutical company in Germany. And Germany's interests, because they have a large pharma and chemical industry, their efforts in Europe have been to normalize it as a pharmaceutical model and give it to the pharma country. So we don't really have this grassroots consumer movement of hemp-filled extract and CBD products the way we have here in the United States. And so that's an example of how that, at a world level there in Europe, it's playing out. Now, that varies a lot, and policies are completely all over the map in Europe concerning both restricted and legal substances like CBD. And so I think it's the same thing here in the States. There's, states, let's say in the Bible Belt, that are just now tolerating CBD for medical use, but are going to really see the benefits of the health industry boom that comes with it, and are also agricultural areas. So for the first time, you've got not only big pharma and big health care around molecules, but you've got it located with big agriculture. And those guys have usually been a little separated, depending on the crop, obviously.
And as we look at the issue of global warming in terms of rising ocean temperatures and deforestation, which is adding more nitrogen into and carbon, the carbon footprint growing, the industrial hemp, the addressing of our environmental issues from a more sustainable, biodegradable, bioplastics fashion seems to be the most obvious path to take. Yet again, there are obstacles politically, socially, and in a corporate sense. But I think the tide is turning. Is it fair to say?
I think so. I think there's a critical tipping point being reached right now in the consumer's mind about the kind of world they want to live in. And I think they're willing to make product choices that reflect that, and they're willing to make lifestyle choices that reflect that. And I think that hemp and biomaterials is a key part of that whole sustainable economy.
Well, David, it's been great speaking with you. You're just a fountain of phenomenal information and on the cutting edge of some of these incredible creations and inventions and developments. I really want to thank you for your time and insights. Look forward to delving deeper into the science of nanotechnology in the near future. And if you want to learn more, you can go to titanbioplastics.com for information on our capabilities and licensing our technology. And thank you to Amy Ansel, great partnering up with you on our inaugural venture on bioplastics and Bioinnov8.
It's going to be a fun adventure, Rich. Absolutely.
Thanks so much. Great being with you both.
Thank you, David. Rich, have a good day.
Thanks now.